In this section, we're going to be looking at parallel and perpendicular lines. To start off with, we're going to look at Theorem 3.7. The theorem states that if two lines are parallel to the same line, then they are parallel to each other. So here we can look at this diagram and we can see that line A is parallel to line B, and line B is parallel to line C. So based on this theorem, we can say that line A is also parallel to line C. The next theorem we're going to look at is Theorem 3.8. This theorem states that in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if we look at this diagram here, and if line M is perpendicular to line T, and line N is also perpendicular to line T, then we can conclude that line M is parallel to line N. The final theorem for this section is Theorem 3.9. Perpendicular transversal theorem. The theorem states, in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So when we look at this diagram, if N is perpendicular to L, and L is parallel to M, then we can conclude that N is also perpendicular to line M. Now we're going to look at an example using the theorems that we just learned. In this example, we're going to prove Theorem 3.8 using a proof. So here we're given the information line R is perpendicular to line T, and line S is also perpendicular to line T. And we want to prove that R is parallel to S. Angle 1 and angle 2 are right angles by the definition of perpendicular. So angle 1 is perpendicular to angle 2. Since corresponding angles are congruent, R is parallel to S.